Hello everyone, welcome to MedDevice. In this video, we're gonna be looking at the lung volumes and capacities, a very interesting topic. So let's start. So first of all, I want to tell you that there are two types of lung volumes and capacities. We have the static lung volumes and capacities and the dynamic lung volumes and capacities. So what is the difference between them? So in the static one, we only measure the lung volumes without recording time. So for example, at the end of inspiration, at the start of inspiration, something like that, we are not really taking time into consideration. But in dynamic lung volumes and capacities, here the lung volumes are measured with respect to time. So for example, if I tell you to exhale and then I ask you how much air did you exhale in the first second, so here since we are talking in with respect to time, these will be called as dynamic lung volumes and capacities. So in this video, we're just going to be learning about the static lung volumes and capacities, and I'll make another video on the dynamic ones. So let's start. So what are we going to be learning in this video? The volumes and capacities. What are lung volumes exactly? So these tell us about the volume of gas in the lungs at a given time. Capacities, on the other hand, they are a combination of different lung volumes. This will become clear in a few minutes from now. Then, how are these lung volumes measured? So, these are measured with the help of a device called spirometer. So, this is a device which measures the volume of air inspired and expired by lungs. So, a graph similar to this is going to be made. Now, it might look a bit confusing right now, but trust me, I'm going to make it very easy for you to remember. So let's go step by step. First, we will be learning about 4 lung volumes and then 4 lung capacities. So let's start with the first one. What is this? This is the tidal volume. What is tidal volume? It is the amount of air inhaled and exhaled during quiet breathing. So right now that you are watching this video, you are doing quiet normal inhalation and exhalation. So you are working at tidal volume. I will write the definitions of all of these in a bit. Now, if I ask you to do deep inspiration, can you do that? Yes, everyone can do that because everyone has reserves. Meaning they can do deep inspiration and expiration beyond tidal volumes or beyond quiet normal breathing. So this here is the IRV or inspiratory reserve volume. So what is this exactly? So imagine a person is doing quiet breathing and did a quiet normal inspiration. Now the amount of air that the person can inspire beyond this will be known as the inspiratory reserve volume. Similarly, if I tell you to exhale as much as you can you do that? Yes, again, because you have the reserves. So imagine if I tell a person to do deep expiration after normal expiration, the amount of air that will be expired by the person will be known as expiratory reserve volume. Now, even after a person expires as much as he can, there will still be some amount of air left in the lungs. This will be known as residual volume. Now, time to come to the capacities. So, capacities, what are they? They are just a combination of different lung volumes. So, first of all, we have the inspiratory capacity. The inspiratory capacity is the addition of tidal volume and IRV or inspiratory reserve volume. And then we have the FRC or functional residual capacity. This is the addition of expiratory reserve volume and the residual volume. Then we have the vital capacity. This is the addition of inspiratory reserve volume, the tidal volume and the expiratory reserve volume. Now finally, if you add all of these volumes, you will get the total lung capacity or TLC. Now let's just define these volumes again one by one so that it becomes more clear. So first of all, we have the tidal volume, which is the amount of air inspired and expired during normal quiet breathing. This is approximately 500 milliliters. This is important to remember. Then we have the inspiratory reserve volume. And keep on comparing these volumes with the graph on the side, which will make it 100 times easier to understand. So this is the additional volume of air that can be inhaled after a normal inhalation. So it is above and beyond the normal inhalation. This is approximately 3000 milliliters. Then we have the expiratory reserve volume. This is the additional volume of air that can be exhaled after a normal exhalation. So normally you exhale and then how much ever you can exhale after that will be known as your expiratory reserve volume. This is about 1200 milliliters. Finally, we have the residual volume. This is the volume of air that will remain in your lungs after maximal exhalation. This will not come out. And this is also approximately 1200 milliliters. Now coming to the capacities, first we have the inspiratory capacity, and as you can see from the graph on the side, how will you define this? This is the maximum volume of air that can be inhaled after a normal exhalation. So as you can see in the graph on the side, the inspiratory capacity is the addition of the tidal volume and the inspiratory reserve volume. So the tidal volume is 500 milliliters and the inspiratory reserve volume is 3000. So the inspiratory capacity is 3500 milliliters. Then we have the functional residual capacity. This is the volume of air that will remain in your lungs after a normal exhalation. So don't get confused, okay? After normal exhalation, the amount of air will be functional residual capacity, and after deep exhalation, the amount of air remaining will be residual volume. So this is the addition of ERV and RV, which is about 2400 milliliters. Then we have the vital capacity. This is the maximum amount of air that can be inhaled after forceful expiration. This is the addition of the three lung volumes IRV, TV, and ERV, which is about 4700 milliliters. Finally, we have the total lung capacity, which is the addition of all of these volumes. And it tells us about the amount of air that the lungs can hold. So after adding all of these volumes, we get a value of about 6 liters. Now some students have confusion, what exactly is this residual volume? Where is it? So to understand this, imagine this balloon is your lung. So you are normally inhaling and exhaling. Now imagine if you opened up the balloon and you let it go. What are you going to end up with? You are going to end up with this. This in a way is showing that you have done maximum exhalation. Now look at this deflated balloon and tell me, would you say is there any air in this still or there is no air? So even though it is deflated, there is still some air which is left in the balloon. So it is similar to that. No matter how much you exhale, there will still be some amount of air which will be left in your lungs. This will be known as residual volume. And this is the volume which cannot be measured by spirometry. Why can't it be measured by spirometry? The answer is very simple. For any air to be measured by the spirometer, the air has to go through the machine. Now the residual volume is in your lungs and it is not going to come out. So since it is not going to go through the machine, it is not going to be measured, right? And so this is an important question to remember. And how much was it? It is approximately 1200 milliliters. That's it for this video. If you have any doubts, so please leave them in the comments or you can message me on Instagram anytime. The link to my Instagram is in the description. Thank you.